derivative of trigonometric function, other than the first derivative, I will also explore the second and third derivative of the last two examples. So let's do the first one. The first one is f of x equals to sine of cosine of tangent 6x. So this one you have some chain rule to do. So f prime of x, the derivative of sine is equals to cosine, right? And then you copy everything inside the sine parentheses. So that is cosine of tangent 6x. And then by chain rule, you take the derivative of this piece, which is cosine of tangent 6x. This is using the chain rule. And then the next step, the cosine becomes a negative sign. So you have f prime of x. I will write everything in one line, but first of all, I will copy the derivative that we just did. So cosine of cosine tangent 6x, and then you multiply. This big dot means I am applying chain rule. The derivative of cosine is negative sine. You have tangent 6x, and then you take the derivative of tangent, so which is right over here. You take the derivative of tangent, which is secant square 6x, and then you take the derivative of 6, which is equals to 6. Or you can just put the 6 in front of the secant if you don't want to do another dot. Number two, we have g of x equals to sine of 7th x and then times cosine 4th power x. This one I highly recommend you to take the 7 and the 4th power out. So sine x to the 7th power and then cosine x to the 4th power. Okay, the power belongs, the 7 belongs to the sine and the 4 belongs to the cosine. The power has nothing to do with x. So what you are doing first is you evaluate the sine of x, whatever that is, you raise to the 7th power. So the x is not going to raise to the 7th power. Same thing for the cosine. You evaluate what cosine of, let's say, cosine of pi over 2. You evaluate what it is, and then you take the result raised to the 4th power. You never, in this function, you do not raise the x to the 4th power. Again, you do not raise the x to the 4th power. Okay, derivative, g prime. What's the product rule? The product rule is fg plus fg, and then f first, g next. So the derivative of sine, you bring the 7 down, you have sine x to the 6th power. The derivative of sine is cosine, right? The derivative of sine is cosine. And then you write cosine x to the 4th power. Thus, you can just write cosine 4th power x. And then plus you copy the f, so that is a sine 7x, and then you bring the 4 down, so you have a cosine x to the 3rd power. The derivative of cosine is negative sine. This one I won't hesitate to just simplify this. So you have a sine 6x, and then you have a cosine 5x, and then a plus, minus, you have a minus. So you have a sine 4, and then sine 8th power x, and then cosine 3rd power x. There you go. This you can always, after simplification, I should not say simplification, you clean everything up a little bit, you can do the second derivative. You can take the second derivative. I prefer not to bother to take the second derivative for this problem because we have 2 second and third derivative problems coming out. So the next problem, I will do the second and the third derivative. So this, I will give you a y equals to 2 times theta sine of theta, and I will find the first derivative, the second derivative, and the third derivative. All right, so y prime, product rule is fg plus fg prime prime. Okay, and then 2 times sine of theta plus 2 theta times cosine of theta. Quick and simple, right? And then double prime. This is a 2 of cosine of theta, and then there is a product, right? So this is a 2 cosine of theta. It was a plus, but when you take the derivative of cosine, the plus becomes a minus. So you have a 2 theta sine of theta, but that is in minus, I will just write like that. So I'm going to need more space, so I will just erase the parenthesis first and then write multiply negative sine of theta. And then what is that equal to? That is 2 cosine theta, 2 plus 2. Okay, let's simplify this. 2 plus 2, right? So you have a 2 plus 2. That is equals to 4. 4, and then cosine theta. And then minus 2 theta sine of theta. Okay, so that is the second, and then let's move on to the third. So the third derivative, what do you have? You have negative 4 sine of theta, right? And then minus, you have to do a product over here, and then you have a 2 sine, and then plus 2 theta cosine of theta. So at the end of the day, you have a negative 6 sine, and then 2 theta cosine of theta. So this is a negative 6 sine of theta, and then minus 2 theta cosine of theta. So if the problem is asking you to do one derivative, you do not need to clean up the derivative. But if the problem asks you to do that multiple times, yes, you do need to clean that up. Okay, let me make sure you have negative 6, right? I am matching up this to my notes, so you have a negative 6 and then minus 2. Yep, you distribute the minus to the plus, then you have a minus 2. And then how do I get this plus over here? How do I get this plus? I took the derivative of... Wait, hold on. Oh, the plus, this is from a product rule. The plus is from a product rule because this is going to be a product rule. So from here to here, this is a product rule. So that is a FG plus FG prime prime. Yep, the plus is from the product rule. And then we are subtracting the whole product rule. So that's why we have a minus 2 cosine of theta. Okay, that is number 3. So moving on to number 4. Let's pick a different color for number 4. So number 4, I have K equals to e to the 3x. And then cosine x, I want to find first derivative, second, and third. So first, e to the 3x times 3 cosine x, and then the derivative of cosine is sine, that will just make this plus becomes a minus. So we have e to the 3x and then sine of x. So that is the first derivative. All right, moving on to the next one. Wait, hold on. I must make a mistake on my notes, not right here. So e to the 3x cosine x and then minus, yep, derivative of sine is cosine, nothing is wrong with that. Second derivative, so that gives me a product. So this one, I will do e to the 3x, and then 3 times 3 is 9 cosine x, and then plus 3e to the 3x. I will just write like that using a pencil, right? You can write negative sine of x, and then you erase this negative and then change this to a minus. Yep, that one is much better. So from here to here, you use a product rule, and then this minus goes here. This minus goes here, and then there is another product rule over there. So that product rule, you have 3e to the 3x sine of x, and then plus e3x, and then cosine x, and then this is in one parenthesis. We do need to clean this up. So double prime. Anything to simplify? 9. You have a 9 minus 1, right? So we have a 9, and then minus a 1. So that is a 8. E to the 3x cosine x, and this is a minus 3 minus another 3, so which is a 6. Yep, clean up. Now we are ready for the third derivative. So the third derivative, another product. So this is e to the 3x, 3 times 8 is 24 cosine x, and then plus 8 e3x negative sine, right? So this is a sine x. I will just erase the plus and then change that to a minus. And then what else? And then this minus goes here. This minus goes here. And then you have e to the 3x. 6 times 3 is 18. The derivative, oh, we are not taking the derivative sign. This is a sine x. And then you add 6e, 3x, and then a cosine x, right? So this is in one parenthesis. We are subtracting the entire product. So the third derivative, what is that equal to? We have 24 plus minus, we have a 24 minus 6, that gives you a 18, right? E to the 3x cosine x minus 8 minus 18, negative 26, e to the 3x, and then we have a sine of x. Miss x in here. Yep, that's it. That's the third derivative. So if you like it, you think this is my teaching, fix your learning, well, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.